To możemy zacząć. Ok. So let's write subject for today. So what we're going to do today is multiplying and dividing of algebraic fractions. Right, so we know how to add fractions and we know how to subtract fractions, and today we will learn how to multiply and how to divide fractions. Okay, so before we go to algebraic fractions, let's see how we multiply and divide simple number fractions. So just to remind ourselves, let's take a look at this example. Let's take 5 over 24 times, let's say, 4 over, let's say, 55, right? Okay, so if we have like simple, normal number arithmetical fractions, what we can do, we can, of course, multiply 5 times 4 in the top, and in the bottom we can multiply 24 times 55. But normally we want to make it a bit easier, because there's no point of multiplying 24 times 55. So what we can do, we can cancel down those fractions. So we can cancel here 5 and 55. So divided by 5 we got 1 and 11. And we can do also the same with 4 and 24. So we get 1 and 6. And then the answer is 1 over 66. Of course, we can cancel fractions in the beginning. So we can do it right here. If we see that 5 and 55, they both can be divided by 5. So we get 111, and the same here, 1 and 6. So we multiply very easily. So the rule is to multiply the top numbers and the bottom numbers. But to make it easier, we cancel down or simplify the fractions. So that's how multiplying goes, multiplication. And what about division? So when we want to divide fractions, okay, let's take 1/5 divided by let's say 3/7. So what do we have to do? We have to change the division into the multiplication, right? But what we have to do, we have to swap this second fraction. So we need to change the numerator and denominator. So now 7 goes to the top and 3 go in the bottom. And then we have simple multiplication. So we can see if we can cancel down some numbers, but well, we can't here, 1, 3, 7, 5, so we cannot cancel any numbers. So we multiply 1 times 7 and 5 times 3. It's 15, right? So this is division. And exactly the same rules we will apply to those fractions. So we are going to do exactly the same thing with multiplication and division. So the rule is the same, but of course, the structure and the operations are a bit different because we work with polynomials. So we don't have numbers, but we have polynomials. All right, so but that's the point. So that's the point of those two operations. So what we have to do, we will try to cancel down some polynomials, and of course we have to remember about the domain. So let's try the first example, and we will see how it works with algebraic fractions. So we will start with 6.42 very simple exercises in the beginning. So the first example is 3 over x times x squared over 6. Right, so we have to multiply those two fractions, which are algebraic fractions because we have x's. So before we multiply those fractions, let's take a look at the domain. So we can see that we have x in the bottom, so we have to get rid of 0 because we cannot have 0, right? So we have domain. We can have all real numbers but without 0. Okay, and now we can see if we can cancel some fractions. So of course we can cancel down the numbers 3 and 6, so we get 1 and 2. But also we can cancel down x squared and x. So we get 1, and here is the first power. So at the end we have 1 times x, so it's x, and 1 times 2, so it's x over 2. Of course we can write it down as half x, but we work with algebraic fractions, so we can leave this this fraction also. We don't have to change. Okay, so very simple at the beginning. Let's take the second one. 1 over x squared times x squared minus x divided by 2. Okay, that's a bit different, slightly different than the first one. So first let's write the domain. So again we have in the bottom we have 2 and x squared. So the only number that we have to get rid of is again 0. So this is our domain. And now let's take a look if we can cancel down these two fractions. Can we do it? Well, at first sight, well, it's not that obvious that we can cancel x squared and x squared minus x. But what we can do, we can take x in front of the bracket from this top of the fraction. So we get x minus 1, right? And now we can see that we can cancel 1x in the top and 1x in the bottom. What is very important, we have to remember that if we want to cancel down the fractions, you need to have multiplication. So when you have minus, you cannot cancel those x squared, right? Some students do this mistake, but if you have minus or plus, you are not allowed to cancel down. So you need to have multiplication. So now I have a dot, so I have multiplication, and now I can easily cancel those two fractions. So I can have 1 here and here x to the power of 1. So I have 1x, x minus 1 by 2. And there's nothing more I can do now, so the only thing I can do here is just to multiply the top numbers and the bottom numbers. And that's it. That's our answer, x minus 1 over 2x. Okay. So this is very important moment to just be careful and not to cancel down here any fractions if we have minus or plus. Okay. So let's go to C. Okay. 4 over x plus 1 times 2x plus 2, 8x squared. Right, first let's deal with domain. So we have all real numbers without, okay, so this number cannot be 0, so it cannot be negative 1x, and 8x squared, so we have to get rid of 0. So those two numbers we have to exclude from the domain. And now let's see what can we do here. So let's see what can we do. Tutaj taka uwaga, słuchajcie, w polsku, bo możemy tutaj na dwa sposoby też zapisywać to działanie. Ja teraz zapiszę troszeczkę inaczej niż wcześniej, bo możemy oczywiście na skosy tutaj skracać od razu, jeżeli damy radę sobie tutaj zobaczyć, że jest ten sam jakiś wielomian. Natomiast też trochę ułatwia sprawę, jak sobie to wymnożymy w taki sposób, czyli wymnożę sobie góry i wymnożę dół. I dla niektórych osób to jest trochę łatwiejsze, więc też tak będę na zmianę, raz tak robić. Dlaczego to jest łatwiejsze? Bo jak sobie zapisuję w takiej formie, to wtedy mam po prostu jeden ułamek. I to, co wtedy już robimy, to jest trochę to, co robiliśmy na początku ułamków algebraicznych, czyli po prostu skracamy ułamek. Nie na krzyż, tak jak tutaj na początku, tylko jakby w jednym ułamku, tak? Staramy się go rozłożyć i staramy się skrócić, co się da. No i teraz na przykład tutaj, no chyba mam nadzieję, że większość widzi już z Was, że jak wyciągniemy dwójkę z 2x plus 2, czyli tutaj sobie zrobię 4 razy 2, no to zostanie mi x plus 1, tak? I na dole mam x plus 1 i mam 8x kwadrat. No i teraz zobaczcie, wszędzie jest mnożenie, tak? I to jest dla nas mega ważne, że mamy to mnożenie. I wtedy możemy sobie spokojnie skracać, co się da. Czyli możemy cały ułamek, przepraszam, wielomian, ten dwumian skrócić. Możemy oczywiście ósemkę, czyli 1, wszędzie jedynki, no i to 4 i 2 też będzie jedynka. No i tak naprawdę zostaje nam 1 przez x kwadrat, tak? I tutaj chodzi o to, że właśnie macie jakby dwie formy zapisu, czyli można to robić w formie dwóch ułamków, tak? Czyli mogłabym, tu jeszcze napiszę, czyli mogłabym zostawić 4 przez x plus 1 razy tutaj tą dwójkę wyciągnąć, o. No i po prostu robić to w taki sposób, nie? Że to z tym, no i potem czwórka z ósemką, czyli 2, 1 i dwójka z dwójką, 1, 1. Czyli wyjdzie dokładnie to samo, natomiast troszeczkę inny jest zapis. Czyli tutaj w tej pierwszej metodzie możemy wszystko od razu do jednego ułamka sprowadzić i potem już patrzeć sobie tylko, co mogę z czym skrócić, co rozłożyć, tak? Ta forma jest o tyle fajniejsza, że jak będziemy mieć takie bardziej rozbudowane wielomiany, to zdecydowanie lepiej mieć je w jednym ułamku, porozkładać wszystkie maksymalnie jak się da. No czasami trzeba będzie jakąś deltę też policzyć, tak? To zaraz takich przykładów też sobie dojdziemy. No i wtedy łatwiej jest dużo mieć to wszystko w jednym ułamku niż w dwóch. No przynajmniej tak mi się wydaje, tak? To też zobaczycie sami, jak to łatwiej Wam będzie się po prostu pracowało. To jest tylko kwestia zapisu, ale ona no, czasami ma ogromne znaczenie. Ok. So this is C. Alright, let me just check. Yeah, everything is alright. Let's go to D. Now we have 4 over x plus 1 times 2x. Oh, sorry, this is C. Sorry. This is C again. So now we want D. Right, x plus 3 over 2 times 16 over x squared minus 9. Okay, so let's write So let's multiply those fractions and let's have one big fraction. So we have x plus 3 times 16, and in the bottom we have 2 times x squared minus 9. Alright, so now we have one fraction, and all we need to do is see if we can cancel down some polynomials or some numbers. So of course the first thing we need to notice is this bracket. And we have to notice that this is a multiplication rule for a squared minus b squared. So we can write it down as x minus 3 times x plus 3. And then the top is the same. Okay, and if we get here, so if we have this fraction, we can easily write down the domain. Let's go to the domain. So we have to exclude 3 and negative 3, right? So those two numbers, they need to get out of the domain. And now we can cancel down the fractions. So we can cancel down x plus 3, x plus 3. So we can have 1 here. And of course 2 and 16, so we get 8 and 1. And at the end we have 8 over x minus 3. And that's our answer. Okay, any questions? Easy as far? Okay. Right, so if there are no questions, let's go to E. We have 2 more examples from this exercise, so now E and F. X minus 1 over 3 times 4x over x squared minus x. Okay, so, let's multiply those two fractions. So I can put brackets here, and we just multiply the top numbers and the bottom numbers. So what we get is x minus 1 times 4x by 3 x squared minus x. Okay, and now let's see if we can cancel down something. So well, at the first look, well, there's nothing we can cancel down right now, but we can do something with this bracket. So we can take x in front of the bracket, and then we get x minus 1. Right, so we need to factorize the polynomials, right? So, well, if you get here, let's just take a look. If we multiply the top numbers and the bottom numbers, so this is the answer really, right? So this is already multiplication, but it is not the answer. It's like when we multiply a fraction like this, let's say 7, 4. Okay, let's do it like this. And if I multiply the top numbers and the bottom numbers, so I get 35 over 70. So of course this is like the result of the multiplication, but we don't leave it like this. We want to make it in short terms. So we want to make it in the simplest way. So of course it is 1/2. And it's exactly this process that we're doing here, right? So this is the result. So this is a multiplication. But we do not leave it like this. We want to make it simpler. So we are trying to cancel down the fraction, right? So that's what we are doing here. It's exactly the same process. So we're trying to factorize the polynomial, and now we can see that we have quite a lot to cancel down. So we can cancel down these two brackets, and also we can cancel down the x's. So we can cancel down this x and this x. And what we get is 4 over 3. And that's our answer. So we get very simple fraction. Of course, we need to put domain to be able to do all all this operation, we need to have, we have to exclude which number? Let's look here. We have to get rid of 0 and 1 to make sure we don't have 0 in the bottom. So that's very important. Let's put exclamation mark just to remember about the domain. It's very important to put domain in algebraic fractions. Okay, and the last one from this exercise, the last example, is 2x minus 4 divided by 5 times 10x divided by x squared minus 4x plus 4. Okay. Okay, and now let's put this together in one fraction. So let's multiply the top numbers and the bottom numbers. Maybe somebody would like to cancel down 5 and 10 straight away here. Of course you can do it. Yeah, definitely. It's multiplication, so you can do it. But I will leave it like this for now, and I will just multiply the top numbers and I will multiply the bottom numbers. And now when I get multiplication and I have one fraction, so now I can of course cancel down 10 and 5 straight away. And then we have to take a look if we can do something with those brackets. So with this bracket, what I can do, well, I can take 2 in front of the brackets, right? So I have 2 times x minus 2 times 2. And in the bottom, well, this bracket is a multiplication rule, of course. It's going to be x minus 2 to the power of 2. So that's what we're going to write here. Okay, and now if we have like this fraction written in this form, we can easily cancel down this bracket with this power, so we get 1, and at the end we have 4 over x minus 2. This is our answer. Of course, we need to write down the domain, and domain is R without 2. Okay, that's our answer. Okay, so after the first exercise, let's try and write down kind of prescription or rules how we multiply algebraic fractions. For now, we only have been multiplying, no division so far, but we will get there. But as we wrote the example for numbers, we know that division is also multiplication. We have to remember only about flipping the other fraction. So like division is the same. So let's write like rules for multiplication. Multiplication of algebraic, of course, of algebraic fractions. Okay, so the first point, let's write domain because it is extremely important. But just remember that you don't have to do it in the beginning, right? You can do it a bit later, because sometimes when we see fraction and the bottom number can be a little bit too difficult to say straight away what is the domain. So you can do it like in the beginning, or let's say that in the beginning if it's possible, right? So if it's easy, maybe like this, if it is easy, right? But you can do it later or in the end. If it is not easy. Okay, let's put it like this. it's exactly what we were doing in the exercises. Sometimes we could write the domain straight away because it was very easy and we can see very easily that we have to get rid of some numbers, but sometimes we can't. So that's the first rule. Then the second rule, let's say we multiply. So if we have the domain, then we multiply the top numbers, so we call them numerators. So multiply the numerators and denominators. And write them as a one fraction. So exactly the same that we did in those examples. So we want to multiply the top numbers, right? The top numbers of the first fraction of the second fraction and put them in the top of the one big fraction, and then do the same with the denominators, so the bottom numbers. And then when we have done the multiplication, we have to factorize, right? Factorize the polynomials. So in Polish it's rozłóż wielomian, rozkładanie, tak? Czyli jeżeli sobie już pomnożymy liczniki, tak, tu są liczniki, tu są mianowniki, jak ktoś nie złapał, czyli mnożymy licznik przez licznik, mianownik przez mianownik, tworzymy jeden pojedynczy ułamek i wtedy, żeby uprościć, tak, czyli dążymy do tego, żeby mieć ułamek w najprostszej formie, tak jak normalnie w liczbach też skracamy do postaci nieskracalnej, to tutaj w wielomianach też dążymy do jak najprostszej formy, czyli nieskracalnej formy wielomianów już nierozkładalnych. No to właśnie wtedy sobie patrzymy, który wielomian mogę rozłożyć, tak? Czyli który zapisać prościej. Oczywiście jakie mamy metody, no to sobie zapiszmy. That we have few methods for factorizing, so we can use taking numbers, take, let's say, something in front of the bracket, right? Front of the bracket. So that's one bracket. So we can take something, let's say something, all right, in general. So we can take some number or some letter in front of the brackets. What else? We can use some multiplication formulas. For example, a squared minus b squared, right? Or a plus b to the power of 2, or a minus b to the power of 2. Of course, we can also use to the power of 3. It's possible to use also these formulas. So we can use some formulas. Then we can use, of course, delta. So if we have quadratic function, we might need to calculate delta and find x1 and x2. And the last method that we, or maybe not the last, well, we can say two more. So we can do grouping. So we can somehow group the algebraic expressions and be able to factorize the polynomial. And the last one, so number 5, is it's the theorem about rational zeros. So we call it PQ method, right? So you have to use the theorem about rational zeros. Czyli tutaj skrótowo my zapisywaliśmy zawsze PQ, natomiast oczywiście jest to całe twierdzenie o wymiernych pierwiastkach, tak? Ale właśnie skrótowo chodzi właśnie o PQ, wymiernych pierwiastkach. Czyli w ostateczności, tak? Ta metoda jest zawsze na końcu. Raczej próbujemy zawsze te pierwsze. Albo wyciągamy przed nawias, albo wzorów szukamy, albo delta, albo grupowanie. Jak już nic z tego w ogóle nie pasuje, no to wtedy kierujemy się do PQ, czyli szukamy wymiernego jakiegoś kandydata na pierwiastka, czyli P, przypominam, jest dzielnikiem wyrazu wolnego, Q jest dzielnikiem wyrazu współczynnika, który jest przy najwyższej potędze x. No i wtedy sprawdzamy, prawda, czy któryś z nich jest pierwiastkiem, czyli musimy podstawić, zobaczyć, czy jest 0. No i wtedy oczywiście cały proces dzielenia przez wielomian i rozkładania. Ale jest to zawsze najwięcej pracy, więc korzystamy z tej metody ostatecznie na samym końcu, jak zweryfikujemy wszystkie pozostałe metody.
Przepraszam,
Tak.
ja właśnie dołączyłem. Mateusz tak.
Dobra, dzięki. Okay, so we have like 5 methods to factorize the polynomials. And if we factorize the polynomials, then the last thing that we have to do, let's put it here, we cancel down the fraction. Cancel down, czyli po prostu skracamy, tak? Kasujemy, skracamy to, co się da w tym ułamku. Czyli zarówno liczby, jak również wielomiany. Po prostu wszystko to, co się da, skracamy. Wtedy, kiedy mamy już oczywiście zapisane wszystko w postaci iloczynu, tak? Pamiętajmy, że skracanie w ułamkach jest możliwe tylko wtedy, jak mamy zapisane wszystko ładnie w postaci iloczynu. Jeżeli jest plus, minus, to nigdy nie skracamy, bo nie mamy do tego po prostu no prawa, jest to błędne, tak? Zgodnie z działaniami matematycznymi. Alright, so there we go. These are 4 rules for multiplication. For the division is going to be more or less the same. The only thing that we would have to add here would be change the division into the multiplication by flipping the second fraction. So that will be the only difference that we would have to put like another point here, that we have to flip the second fraction by which we divide. Okay, let's take a look at another exercise that we got here. Let's take 643. 643. We will choose 3 examples this time. Let's take ACF. Okay. Right, what do we have here? We have 3x squared plus 3x by x squared minus 1 times x minus 1 by 6x. Okay, so in our rules we have the first point like domain, but this time I will wait with the domain because, well, of course I could say straight away which numbers I have to exclude, but let me just give me a few minutes before I do it. So first, what I want to do now is point 2, so I multiply the top numbers and the bottom numbers. So let's multiply them. So we have 3x squared plus 3x times x minus 1, and in the bottom we have x squared minus 1 times 6x. Right, and now, okay, so now we have one fraction, one big fraction, and now what we want to do is factorize, right? So we now factorize the brackets or the polynomials in the brackets. So let's see what we can do. Well, the one in the bottom, it's a multiplication rule, right? Multiplication a squared minus b squared, so it's going to be x minus 1, x plus 1 times 6x. And this bracket here, we can take 3x in front of the bracket, and we get x plus 1 times x minus 1. Right. And at this point, when we get here, it's very easy to write the main, so I will do it right now. It's r without 1, -1, and 0. So -1, 0, 1. Okay, so you see here that when we have simple polynomials, it's much easier to write the main. Okay, and now the only thing we need to do is to cancel down the fractions. So of course we can cancel down x minus 1, x plus 1, and even x's, and 3 and 6. So we got, in the end, we get 1/2. And this is our fraction in the end. So we have everything cancelled down. Very nicely done. Okay, so let me write c, x squared plus 8x plus 7 times x plus 1, 14 minus 2x. Okay. Right, and I will wait with the main again. Right, so first let's multiply the top numbers or the top polynomials and the bottom polynomials. So I get 49 minus x squared plus 1. And in the bottom we have x squared plus 8x plus 7 times 14 minus 2x. Okay. Alright, and now factorize, right? Again, so factorize. Okay, so what can we do here with our polynomials? Let's start with the top one, because it's quite easy. We have a squared minus b squared. Okay, so I'm going to write down here. So we have 7 minus x and 7 plus x times x plus 1. Done. So the top of the fraction is done. Now let's look in the bottom. Well, it's a bit complicated because this one, well, there's no multiplication rule. So what do we have to do? Well, I guess we need to calculate delta, right? Because this is quadratic function. Let me just find some space here. Okay, so I will take this function, right, this one, x squared plus 8x plus 7. This is quadratic function, and we need to use delta to find x1, x2. Okay, so let's calculate delta is 8 squared minus 4 times 1 times 7. So it's 64. Dobra, no coś mi się tutaj słuchawki poładowały. So it's 64 minus 28. Okay, so what we get here, 64 minus 20 is 44, so it's 36. Okay, so it looks good. The square root of 36 is 6. So we get x1 is, let's look here, as negative b, so it's minus 8 minus 6 divided by 2. So it's negative 14 divided by 2, so it's negative 7. Right? And x2 is minus 8 plus 6 divided by 2, so it's negative 2 by 2. It's negative 1. Okay, so this is our first example that we have to use delta, right? So this need delta to factorize this polynomial. Okay, so now I can write here down that it is x plus 7. Oh, sorry. X plus 7 and x plus 1. Okay, and there's also this bracket. So I can take 2 in front of the brackets and I get 7 minus x. Okay, there we go. We have very simple polynomials now. And we can do a lot of cancelling down because we can cancel this and this bracket, then this one and this one and this one and this one. So what we get in the end is 1/2 again. All right, so very easy, very nice answer. And of course, let's take a look at the domain in the end. So we can, to see domain, it's good to look at this bottom here. So we need to get rid of -7, 7, and -1. So -7, -1, and 7. And this is it. So the answer is 1/2 with the domain real numbers without -7, -1, and 7. So very nice example, because we had to use here a lot of, well, maybe not a lot of, but like we needed to use 3 methods. So we used taking number in front of the brackets. Then we used the multiplication rule for a squared minus b squared. And we used delta. So we used 3 different methods for factorizing. So very good example to see how can we use all different methods. Tylko wyjdę, słuchajcie, i już sobie zamknę.